captured geometry in the skeleton can now be wrapped up into a digital asset that can be used as the foundation for the animation rig. To start, you will export the geometry and its capture weights and the skeleton, then embed these into the digital asset file. This will help make the capture rig more efficient when animating the character. So now that we have this all set up, what we want to do is flatten some of this skeleton capturing out using a ROP geometry output node. So this will allow us to take the geometry and export it to a file on disk. So we're going to give that name of furdude and capped. So for capture.bgo. We're going to save that to disk. Now, at a superficial level, this file is exactly the same as the file we originally had, except it now has capture information in it that can be fed into the deform node. We're going to also create a ROP geometry output for the skeleton itself. So that will just flatten everything on that front as well. And we'll call this furdude_skell. So these two nodes will be sort of flattened version of what we've built here in the capture node. And later on, if you ever want to update any of this, you can update it, put it back into these files, and then upload these files back into the digital asset. This allows us sort of a two-stage process. Set things up, and then carry them over. So we're going to take the original directory we had, and we're going to call that furdude capture, so we can go back to that later if we need to. And we'll just move that over here. And what we can do now is go get one of those files that we put on disk. So getting a file, we'll go to the geo directory and get the capture one and accept that. And just press enter to place that at the origin. So like I said, it looks exactly, if we dive, let's find those two. Oh, there we go. There's the original capture. Here's the new one. And we're going to hide both of them so that we only see them when we go into the network. So we double click into there, now we can see it. So again, it looks exactly like where we started way back at the beginning. The difference is there's capture attributes and information on here that will help us. Now we're going to alt drag this over, and we're going to go get the skeleton version as well. It also has attributes necessary for the skeleton. And we'll just call that skell. Perfect. So once we have these two, we're going to want to wrap them up into a digital asset. So we're going to go create asset, and it's a new digital asset, and we're going to give it the name furdude, and we're going to call it capture rig. So this is the capture rig, which is at the core of our other rig. Now we're going to put it into our HDA directory, and we're going to put into it an HDA called just furdude, because we're actually going to put other digital assets into the same HDA file. We're going to press accept. So this puts a file on disk that contains this network, and everything about it. Now these type properties come up. We're going to change the outputs rather to 3, and press accept. And we'll just call this furdude capture rig. Now, once we have that, we need to set it up properly. So we need to go inside, and we want to set up 3 outputs. And we said that we could have a maximum of 3. And the way to put those is with these output nodes. So we're going to wire the geometry into the first one, and we're just going to rename that we're going to have an index of 0 and name that capture geo. Okay, so that's we know that that's coming out as the captured geo, ready to go. We're going to alt and drag a couple times to get 2 more. Now they're going to have an error on them initially, and the reason for that is they need to have a unique index. So that one's going to have an index of 1, and this one's going to have an index of 2. So 0, 1, 2. We're going to call this one the rest skeleton, and the last one will be called the anim skeleton. So that's where you're going to do any animation, is along the third path coming out. Now, once we've added these nodes, let's set the display on the capture geo. Once we have these, we want to save this back into the asset of the asset definition. But the way we're going to do that is we're going to bring up edit op type properties, and we're going to go to extra files, because one of the things is currently those two file nodes are referencing files on disk, which means that doesn't make this asset very portable. So what we're going to do is we're going to literally load those two digital assets, the capture and the scale BGO, we're going to load them into the HDA file. So you'll be grabbing those locally within the HDA file instead of somewhere on disk. So we put those in. That's perfect. And once those are in, we just press accept. So that'll save the asset as it is so far. But we're still not quite ready yet because these two file nodes are still referencing the one on disk instead of the one in the asset. So we have to click on there instead and click on opdef. And then go to SOP. Go find FurDude, the FurDude digital asset capture rig. And there we go. And those are the two files that we put on disk there. So we're going to get the first one and press accept, and you see how it has a different expression up here, and we could type that out, or we can copy from there, bring that over to here and put that there. So now both of them are referencing on disk, and we see there's the skeleton and there's the geometry. So once we have those, we're ready to go. What we need to do is simply go and lock the asset, and we want to save the changes because we just made a couple changes. So now you see people can't touch what's going on inside that asset, and now we have 3 outputs. To test these, we're going to put a bone deform node down, just like we had before, and we're going to just shift select these 3 outputs, and then connect them to that input. Now we're going to set the display on the bone deform, and now we can put down another rig pose. We're going to put that here on the 3rd output there, and all we have to do is, just like before, we can grab any of the bones here using got to make sure the handle tool is active, and there we go, we can start to deform. And so even though we flattened it and all the biharmonic and all those other nodes are gone, the results of those are burned into those BGO files, and we're taking advantage of those here in this capture rig asset. So it flattens things, makes things a little more efficient, and that's perfect for the rig. Now, the next thing we're going to do is start building a control rig to manipulate this for animators.